Okay, hello everyone. Let us now discuss properties of trigonometric functions. So let's read the first line. So in algebra, an even function are functions for which f of negative x is equal to f of x, and odd functions are functions for which f of negative x is equal to negative f of x. So we will see this later in an example. So in trigonometry, so cosine is an even function and sine is an odd function. Okay. So we will see that later. So let's focus for now on the domain and ranges of trigonometric functions. So let's take a look at the sine theta and cosine theta. So the domains are the same and the range are the same. So negative infinity to positive infinity and negative 1 to 1. Okay, so let's take a look at the graph and let's see if it really is true. Okay, so as you can see here, for y is equal to sine x, the domain negative infinity to positive infinity, and the range is 1 to negative 1. Okay, negative 1 to 1. Okay, so how about cosine theta? So the same thing. So as you can see here, they have the same domain and same range. Okay, so let's take a look at y is equal to tangent theta. So looks kind of bizarre, right? So there are many asymptotes. So let's take a look at the it says here that the domain is all real numbers such that theta is not equal to 2n plus 1 and pi over 2. Okay, so where the n are integers. So let's say if n is 0, so we will get pi over 2, right? So let's plot x is equal to pi over 2. How about if n is negative 1? If n is negative 1, you will get negative pi over 2. So as you can see, these are the asymptotes and you can add more. So this will also go to infinity also. Okay, so that's it for tangent theta. Let's take a look at cosecant. Okay, cosecant is also uh, it's kind of weird, but that is the graph of the cosecant theta. Okay, so let's take a look at the asymptotes. So when theta is equal to is a multiple of pi. So n are integers again. Let's try it out. What if x is pi and negative pi? So there you have it. So if n is 0, of course that would be that would pass through the origin. Okay, that would be x is equal to 0. So negative 2, if n is negative 2, so we get negative 2 pi and x equal to 2 pi. 2, that would be 2 pi. Okay, so those are the asymptotes, and as you can see here, um, this is cosecant, right? So as you can see here, the range is from negative 1 to negative infinity, and union positive 1 to positive infinity. Okay, so that's cosecant, and let's take a look at secant. And secant has the same asymptotes as the tangent. Okay, so let's try to see if that is really the case. So as you can see here, they have the same asymptotes and the range is different. So the range for secant is the same as the cosecant. Okay, so and last but not least is the cotangent. So let's take a look at cotangent. Okay, so there you have it. This is the inverse of tangent, and then the asymptotes of cotangent are the same as the asymptotes of the cosecant. Okay, so let's turn those on again. So as you can see, so those are the domain and ranges of the trigonometric functions. Okay, so now let's apply the odd and even concept here. Okay, so in an example, so this is our first example. Okay, they have here show that secant negative theta is equal to secant theta. Then determine if it is an even or odd function. Okay, so let's try. So secant negative theta. Oh, but first we should determine what secant theta is. So secant theta, we know, is 1 over cosine theta, right? Okay, so let's try. Secant negative theta is equal to 1 over cosine negative theta. So we know that cosine cosine theta is even. Therefore, cosine negative theta is equal to 1 over cosine theta. Because if you go back here, you can see here that cosine theta is equal to cosine negative theta. As you can see here, it's the same. So therefore, it is equal to this is equal to secant of theta. So therefore, we can say therefore secant theta is even. Okay, so how about another example here? How about tangent theta? So tangent theta, as you know, is sine theta over cosine theta, right? So let's try to substitute negative theta here. So that would be sine of negative theta over cosine of negative theta. So from our statement here, we know that sine is odd, right? So we have here sine theta is equal to negative sine theta. Okay, so let's substitute that. So this is negative sine of theta all over cosine. What is cosine of negative theta? That is the same as cosine theta. Okay, so this is the negative version of our original um, sine theta over cosine theta right here. Therefore, tangent theta is odd. Okay, so that's it for this video, and hope you learned something. See you in the next video.